greater than that 1300. So that is why I chose this as my alternative. This is going to be a normal distribution with the mean as the expected value, which would be the 1300. And my standard deviation for this is going to be the standard deviation divided by, because it is a sample, divided by my number in the sample. So my standard deviation they gave me previously was 56. The number in my sample is 10. So this is the value that I'm going to plug in for that sample standard deviation, which is 17.7088. And I'll probably key that entire thing in whenever I go to work my problems. Now the probability of this type 1 error, which is alpha, so it's probability of this type 1 error, which specifically is the probability that x bar, or the sample mean, is greater than 1311.26 when in reality the mean is actually 1300. So how we're going to calculate this is we're just going to use a normal distribution. We're going to do a normal CDF. The lower limit on this is going to be 1311.26. The upper limit on this is going to be positive infinity. And then my mean is 1300. And my standard deviation is the 17.7088. Now how I get to this on my calculator is I'm going to do second distribution, the blue key, and then I'm going to hit the distribution key, and I'm going to scroll down to normal CDF. Then it's going to say what's your lower limit, what's your upper. How I key in this upper, how do I key in that infinity, is I'm going to hit 1, and then you can hit times 10 to the 99 because that's a big enough number for it to take it as infinity. I usually just hit second, which is your shift key, second, and then I hit that double E key, and that means times 10 to the, this sequence means 1 times 10 to the, and then I have a 99 there, and that means infinity. So that's usually what I key in. And when I crunch that out, that's what I'll get as my probability. The next part of this problem, they change it up a little bit, and they say what's the probability when the mean is equal to 1350. So the mean changes on this. There's standard deviation. It doesn't change because they didn't change that at all. And then we're going to do the probability of my type 2 error, which is actually beta. So the probability of, I'll just go type 2 error. And the probability of this type 2 error is the probability that the mixture is judged unsatisfactory when in fact the mean is 1350. So I'm going to write that down. So the probability of this type 2 error is the probability that my sample is less than 1311.26 when in fact it really does equal the 1350. This is a type 2 error, and what I'll do for this is a normal CDF using the calculator. My lower limit on this would be negative infinity. And just put a negative in front of the 1 times 10 to the 99th. My upper limit is 1311.26. My mean is 1350 because we changed this problem from before. And then 17.7088. And then you'll get that value when you crunch the number on your calculator. On this next part, they're actually wanting you to give those mean values when given the area or the probability with this significance level of 0.05. So this is an inverse normal. get those mean values. For the area is 0.95. The mean is 1300. And my standard deviation is 177,088. Crunch those numbers and you will get what is sitting there. Okay, on this one you're just supposed to change, I should change the color. You're supposed to do part C again, but instead of this 131126, what I want you to key in is this value right here. So just do the exact same normal CDF, everything's the same, but plug this value in for your upper limit and you'll get what you're looking for. This problem tells you what to do in place of X bar, and you're just going to crunch the numbers in place of X bar. You'll key in 1331.26. Of course, your standard deviation is the same. It's the 56, I think it was. And then this would be the 10 is your N, and then you just crunch those numbers. After reading through number 6, what they were looking for was they wanted to know what the true average braking distance for the new design was, and we're going to develop a hypothesis test based on that. I just looked at their numbers on B and went through to see what would be reasonable. For C, they were wanting to know what significance level we would have with these particular types of parameters. So what I did was I just basically went through to find a normal CDF. I found the probability. Normal CDF. My lower limit was negative infinity. Just basing it off this thing right here. My upper limit was the 115.2. My mean was the 120. And my standard deviation was, remember I have a sample here, so I take my standard deviation, which is 18 for me, see them up there, divided by the square root of the number of samples or observations that I have. That's a 36 on this one, and then number crunch that to get my value. The next question asks me about a left-tailed test, because that is what I'm doing, and what would I do for an area here at 0.001, and what would that mean be if this was my area? So in order to get that mean, I'm going to do an inverse normal. The area 0.001 with a mean of 120 and a standard deviation of this 18 divided by the square root of 36. Let me just go ahead and tell you that I'm just going to write that down as a 3 because my number was nice and it was easy. So this number here is actually that right there. You might not have as pretty a number, but mine was nice. Then the next question asks me for actually a beta. So it's actually wanting this beta of 115. So they're asking what's the probability that, because we're looking for an error here, that x is greater than 115.2 when the mean is 120. So once again, I'm going to do a normal CDF. Uh, 115 is going to be my lower limit, 115.2. Positive infinity is my upper limit. 115 is my mean. 3 is my standard deviation. Of course, it's that same 3, 18 divided by the square root of 36. And in order to get these, I'm just going to plug in basically what they tell me to and get those values. You can work it to get your X bar, because basically for each one you're going to get your X bar. I'm just going to show you how to do it for the first one. First one says I've got this negative 2.19, and it's going to equal X bar minus my mean, which is 120, over this 3, which is my standard deviation divided by n. When you do this, you'll get an x bar, if you do the algebra of that, you'll get an x bar of 113.43. And that's not what they asked for. What they asked for was the actual probability on this. So you're going to do a normal CDF, and it's going to be from negative infinity all the way up to 113.43. Then your mean is 120, and your standard deviation is 3, and then you'll get that number, plug it in there. You do the exact same thing for the other one. Reading through this problem, you will notice that they're trying to test to see if it differs from the 5.5 mean value. That's why I chose this one right here. They want the actual z values. You get those z values from the chart that I'm getting ready to show you. Know that it is 0.01 alpha. It is a two-sided test, so that's what I'm going to look for. This would be a left-tailed test right here. If I was looking at this one, this would be a right-tailed test. I'm going to my table of values to get those for 0.01. 0.01 is right here. Two-tailed test, 0.01 is 2.576, and I just plug those numbers in. Notice that they wanted me to round this to the second decimal, so I did that. Let's see. If you want to avoid using that table, you can actually cheat a little bit, and you can just do an inverse normal, which is what I usually do, because I'm not going to go look up the chart. I just do an inverse normal. The area, since it's two-tailed, I cut this 0.01 in half and do 0.005 for my area. Then I do the 0 for the mean, and then one just called a standard normal. That's what this z value is for a standard normal with the mean of 0 and the standard deviation of 1. And you'll get the negative 2.58, and I'll know that it's two-tailed, so the other one is positive 2.58. Computing the test value, I'll just plug that in. I'm going to be doing a z-test, so I'll hit stat. I'm going to scroll to tests. I'm going to go to z-test since this is a standard normal test. And I will make sure that my cursor is on stats, because I didn't edit this in a list. My mu naught is 5.5. My standard deviation is 0.32. My x bar is 5.24. My n is 16. And I choose the not equal to mu naught option, because that's my hypothesis test, and you will get a z value of negative 3.25. And seeing as this value is indeed less than my z of negative 2.58, I will say reject the null on my next slide here. We'll pull up, reject the null. Alright, this is what we're actually looking for. We're looking for the probability of 1 minus this beta error of the 5.6. I'm going to write down those values. Alright, I got a lot of stuff written down here because it was a pile of nonsense. What I did was I did the plus and minus version of this 2.58 with this mu naught minus mu over my standard deviation. I found what that was. That's using a standard normal, so I did 1 minus the standard normal of this value that the numbers crunched out to be, and calculated and got this 0.09. For the number of samples, I used just the general formula that I used before, where I had the width over it's the 2 times z, where there's my z values and the standard deviation with my width, which is a problem that I've done before in chapter 7, so crunch those values.